Okay, hello everyone. We are Ralph, virtual reality layout of internal facilities. My name is Lucinda. My group members are Junjie, Ben, and Anthony. Today we'll be covering major key aspects of our project and our presentation. So inadequate storage space and inefficient use of available storage are huge problems in warehouses with poor facilities and can have significant long-term consequences leading to longer cycle times or increased cost. Essentially, we designed a VR software of a lab so that the user is able to optimize their 3D environment, allow them to view the facility in multiple first-person perspectives through Unity using real-world assets. Our software, Ralph, will be useful to companies that wish to rearrange their layouts without having to physically move everything. It'll increase safety in the workplace, reduce costs, and many other factors. There are many similar products available. However, Ralph is intended to improve upon that. For instance, AutoCAD is a graphic design application that provides a 2D layout. Common issues with this app is that it's not suited for 3D design because it has fewer options. For example, it cannot be used in complex designs and in complex programming. Another software is Isometric Modeling. It lacks shape and depth, and it's more useful for rectangular than curved shapes. Some of you may know the utilization of AR softwares in housing websites, which provides a visual of the interior structure of your home. Currently, because of COVID, the software has grown immensely. However, it lacks essential features. It does not allow the user to edit objects freely and only portrays a wide-angle view of the layout, and surrounding items at the edge will be distorted.
So the way that we plan on improving upon the aforementioned design layout options is by combining them with the new technologies of virtual reality, as well as the tried and true methods of optimization that have been used by engineers and mathematicians for many years now. In a facility with an existing layout, we can simply optimize it by reorganizing the existing contents with the process objective in mind, and we can expect this to make a more efficient use of the available space, as well as increase workflow between departments.
We use Unity as our primary modeling and programming software. In the modeling section, we add a lot of large equipment, which is similar to the real lab. We also add a lot of small devices to make it more designed for. Our VR devices is an Oculus Rift S, and the glasses and the handle are already view connected to the Unity. And we're gonna show a little video about what we have.
Hello everyone, we're the group 15, where I'm now putting on my VR glasses and start running my program in Unity, and my handle is up running, and I'm outside of the door of the laboratory. And now I'm gonna enter the laboratory to take a look. We have added a lot of equipment inside of it, includes a big machine like CNC machine, also the small equipment. Now I'm gonna try to grab a keyboard like this. So grab the monitor and put it down. The yellow square shows the area I occupied, which was used later. And now I'm gonna walk around of the room and make sure there's no problem inside. And now we're coming to our main operational system, which is a regular TV in the real lab, but we added some special feature for that. In the up right corner is a mini map for the entire lab. On the left hand, there are 3 sections that we can manipulate. You can see there are 3 areas represent the 3 functions. The first one is to change the way that we can grab. But right now, my hand is too far away to click the bottom above, so I'm going to press the bottom on my handle to change my grab method. And now my hand was changed to the array, so I can start to click the bottom above. The first option also changed from the hand to the array. The second function is to optimize the existing internal layout of the laboratory, and I'm gonna click this bottom with my array, and this is gonna take some time because my computer is slow. Okay, all set. Now let's take a look at the current layout, where all the devices has been turned into the optimized layout according to the correct calculation. And then we can also see this mini-map, so all of the equipment was at the edge of the laboratory. And this is a working area, all the computers was put in here, so people can sit together and work together. The third part is what we want to do, but we didn't finish that. We want the user to input their own dimension to create their own devices. And finally, this is our product. I hope you like it, and thank you for you guys to watch it. Hello everyone, we're the group.
So for our major scientific component, it was optimization through the CRAFT method, which stands for Computerized Relative Allocation of Facilities Technique. So what the CRAFT method does is it's used for improvement of an existing facility, and it uses a from-to chart, which is basically just the flow data between departments, and it uses that as input data. And the goal is to minimize a layout cost, which is based off the distance-based objective function you could see above. So in that equation, where our goal is to minimize the flow between departments multiplied by the carrying cost, which is always 1, multiplied by the distance between departments. And just an important thing to note is that departments are not required to be rectangular. However, the buildings normally are. But as is the case with our building, there is workarounds if the layout isn't rectangular. So here's a diagram of our original layout. So in the diagram, the white boxes represent just OPACE. The yellow box represents where Junjie was standing in the video. And then, as I was talking about in the previous slide, the gray area that represents dummy departments. So basically, they're fixed points that don't add to the layout cost, and they're just used to help shape the lab. And next slide. Yep. So here we have our optimized layout after doing the CRAFT method. And as you can see, all the blank space is centralized. So it allows for smoother flow. And the departments that interact with each other are more closely together, which should minimize the cost. So for the we had a flow matrix describing the flow and the interaction between each department within the lab. And then we have 2 distance matrices. The first one representing the initial layout and the second one representing the new layout. So when you multiply the flow by the distance, it gives a cost matrix, and the sum of that gives the total cost of the layout. So the initial one, the total cost was $2,507, whereas our new layout, the cost drastically decreased and it was at $1,731.
So due to the ongoing pandemic, we felt that it would be in our best interest to continue working remotely throughout the duration of this course. Unfortunately, this meant that we weren't all able to work together in VR, as only one of our group members owns a set of VR equipment. Additionally, since we also weren't able to meet on campus, we couldn't physically implement our improved test layout in person at the core building. However, as you saw in the previous slide, the data we collected from our objective function shows that we achieved a significantly decreased cost over the previous layout. Luckily for us, since the bulk of our project consisted primarily of programming, the overall impact of the pandemic was low on the progress of our project. The biggest risk that we faced in undertaking this project was trying to learn C#, which is Unity's native programming language. And this was because of how different it was from other programming languages that we've used in the past. We decided that we were spending too much time learning how to program in C# rather than actually producing results. And in the end, we decided that it would be most time effective to recode in Python, as well as finish our project in Python. Going hand in hand with trying to keep all of our work on Unity, we also tried using their integrated collaboration feature, Unity Collaborate. And while it was relatively effective in the beginning of our project, we ran into many errors, most likely due to differences in operating software and version history as we progressed in the project. When we switched from C# to Python, we decided that it would be simple to share our scripts over Google Drive as opposed to continuing to use Unity Collaborate. So in summary, Ralph is a modern, time-effective, easy-to-use and learn solution to optimally designing both complex and simple facilities. We felt that the integration of VR really opens up the applications for generalized design layout software. So with that, we'll conclude our presentation, and we'd like to now open the floor to any questions that you might have. So if there'll be no questions, thank you for watching.